Hello and welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem 65, valid number. Before we do, I just want to ask that you subscribe to the channel. I'm making a lot of these videos for you guys and I want to grow. Help me grow. Subscribe to the channel. Alright, a valid number can be split up into these components in this order. A decimal number or an integer, an optional e or e followed by an integer. This represents scientific notation. A decimal number can be split up into these components in this order: a sign character, plus or minus, one of the following formats, one or more digits followed by a dot, one or more digits followed by a dot, followed by one or more digits, a dot followed by one or more digits. An integer can be split up into the following components in this order: an optional sign character, plus or minus, one or more digits. And for example, all of the following are valid numbers: 2, 0, 0, 8, 9, minus 0.1, plus 3.14, 4 point, minus 0.9, 2e10, minus 9, 0, e3, on and on and on, while the following are not valid numbers: ABC, obviously that's a string, 1a, 1e, e3, 9, e25, minus minus 6, minus plus 3, 95, A54, E53. Given a string S, return true if it is a valid number. So this question isn't necessarily that difficult. It's marked as a hard, and the only reason it's hard is because, as you can see, there's so many cases that we need to consider, and we need to capture all of the edge cases to make sure that we actually get our final solution. So this question is more of, can you catch every single edge case and handle all the cases in a logical order than it is of coming up with some crazy algorithm to solve it. It's more of, can you cover all of your bases? So instead of going over why every single one of these is valid or isn't valid, I think what's easier is just if we go into the code editor and we're going to type this out line by line, and we're going to explain why things work, why things don't work. So I'll see you there and we'll walk through this. It's quite a long question. It's quite a lot of code, but everything will be gone over line by line and explained meticulously in a way that every single edge case is going to be hit and in a way that you can easily understand it. So I'll see you in the code editor. Okay, we are in the code editor. Now it's time to write the code. So we know off the bat that there's a few things which are not going to make a character, which are going to make a number invalid. And the first is, obviously, we can't have more than one decimal in a number, right? It doesn't make sense. We never have like 4.1 or 4.1.2, right? That's not a valid number. So we know off the bat that we can only use a decimal once. So let's keep track of that. So we're going to say decimal used, and this is going to be false. We haven't used our one allowed decimal yet. Now, another thing that needs to happen for us to have a valid number is that we need to see at least one integer, right? We could have minus e, which generally is fine because we're allowed to have e's for scientific notation, but if there's no number, then this isn't valid, right? We need to see at least one number. So we need to keep track of whether or not we've actually seen a number somewhere here. So we're going to say number seen, and this is also going to be equal false because we haven't seen anything yet. What we're going to do here is we're going to have a while loop, and we're going to iterate character by character and check each character as we go along. And if ever we get something that's invalid, then we're simply going to return false. Otherwise, we're going to keep going. And if we're able to get to the end of the string, and we haven't returned false, and we have seen at least one number, then our number is valid. Otherwise, we return false. So let's go through this. So we're going to go index by index. So obviously, we're going to initialize our variable to 0 because that's the first index we want to check. Now remember that in our thing, we're allowed to have a plus or a minus, which is allowed to happen at the beginning of a number, right? Or after an e. So we want to check whether or not the first character is a plus or a minus. So we're going to say if s of I equals to plus or minus, then that's allowed, right? We're allowed to have a plus or minus at the front of our number. So if this is the case, we want to move our I up by 1. Otherwise, it's going to stay at 0. Now what we're going to do is we're going to say while I is less than the length of s, we want to get the current character, which is going to be s of I. And now we need to start checking all of our edge cases. So remember that the only letters that are allowed are these lowercase e or uppercase e, and that indicates that we're going to have a scientific notation. If we have any other character, it's immediately invalid. So we're going to say if current char dot is alpha, so if it's a character, we want to check whether that character is an e or an e. So we're going to say if cur char is not in, so if it's not an lowercase or uppercase e, then we return false. We have some character in here that's not valid, we get rid of it. Otherwise, what we want to do is we need to make sure that we've actually seen a number before we've gotten to this e. If we look at our example of not valid things, this is not valid for the reason that we have not seen a number before the e. We need to see a number before the e, right? So we want to check whether we've seen a number at this point. And remember that when we have scientific notation, when we have e or e, it must be followed by an integer. So at this point, if we've seen an e, we need to have seen at least one number before it, and whatever values come after the e, so for example, in this case, e minus 1, this needs to be a valid integer. So we're going to write a function, and we'll do it in a second. We're going to say self.isValidInteger, and we're going to pass in the string, right? So s of I, everything after our e. If s of I is our e, then everything after it must be a valid integer. If both these are true, then our number is a valid number. If not, then it's false. So we'll do the is valid integer later because it's actually quite simple and we can reuse some of the logic that we're going to use in this main function. So this handles the first case where we have a character, right? And we made sure that it was an e. If it wasn't, we return false. And if it is, we want to make sure that we've seen a number and that the number after it is a valid integer. Cool. Now let's handle the next thing we can see, which is going to be a decimal, right? So we're going to say else if the current character is a decimal, then what we want to do here is check, have we already used our one allowed decimal? So we're going to say if decimal used, so if we've already used it, then we now have a second decimal, which is not allowed. So we can simply return false. Otherwise, we just want to say we've used our decimal. So decimal used is now going to be equal true, and we can basically continue to the next thing. Otherwise, what's something else we could see? Well, we could see another plus, like in this example. So at this point, we've already handled the case where the plus occurs at the beginning. So if we now see, and we moved our index up, right? So if we now see a plus or a minus, it's in an invalid location, therefore we want to be returning false. So else if the current character is in, so if it's in either a minus or a plus, then we know that this is invalid, right? This would be this case, the minus plus 3. This isn't right. So if this happens, we can simply return false. Otherwise, the only thing left, right, because those are the only things that we're going to see. If you look at our kind of constraints here, we're only going to see English letters, both uppercase and lowercase, which we've handled here. You might get a plus or a minus, which we just handled here. You might get a dot, which we just handled here, or a digit. So the last case is that we have a digit here, which means that we have seen a number. So we're going to say number, oops, this should be number seen here. Number, so that means that we've seen a number, so we can mark it as true. Otherwise, the last thing that we need to do is simply just increment our I by 1, and we are going to go through our while loop. Now, I mentioned that the last thing that we need to do once this while loop breaks, because we're done, either we'll have returned false inside of here, or we're now at the end of the loop. And the last thing that we want to make sure is that we've actually seen a number, because if we make it through and we haven't seen a number, then that means that this isn't a valid thing. So, we can have the string with just a minus, right? So this is valid because it's a minus at the beginning, but since we haven't actually seen a number, this isn't a valid number in and of itself. So all we need to do is return number seen. So if number seen is true, that means that we've seen at least one digit and none of these other conditions were broken. Therefore, we have a valid number. So at this point, the only thing that we have to do now is actually just write our isValid integer, which is going to be essentially the same logic we have here, except it's going to be a little bit simpler because integers are different from the numbers that we can accept before an e. So let me just make sure I don't mess up my indentation here. This should be fine. So we're going to say def isValid integer, and this is going to take a string, right? We'll say string to test, right? So what we want to do is we actually want to make sure that we have a string passed into us. It could be the case that, slicing our original string s from the index i+1 to the end actually is an empty string, right? It could be the case that our s of I is actually the last index and it was like an e here. Therefore, there's nothing after it, which is not valid, right? Every time we have an e, there must be a number after it. Otherwise, it's an invalid, right? One e is not valid because there's nothing after the e. We can't just have e by itself. So we want to check whether or not the string is actually a valid string, so, non-empty. So we're going to say if not string to test. So if our string is empty, then that's going to be false because obviously an empty string is not a valid integer. So we return false here. And the same thing for an integer, we're going to make sure that we've seen at least one number, right? So we're going to say number seen, and obviously we haven't seen a number yet, so this is false. And we're going to do the same thing that we did in our main function here, which is going to be, we're going to set I equal to 0, and we're going to say we want to check whether or not the first character in our integer is a plus or minus, because look, an integer can be split up into a sign character and then one or more digits. So let's handle the case where we actually have a sign character. So we're going to say if string to test of I is actually in plus or minus. So if it's a plus or minus, that's fine because it's the very first character. So in this case, we just move I up, and that's totally allowed. Now we're going to have the same while loop that we had before. So we're going to say while I less than len string to test. Again, we're going to extract the current character. We're going to say current character is going to be string to test of I. And now, as the only thing that's valid in an integer after we've already handled the potential sign character at the front is only digits are allowed. So if we see anything that's not a digit, immediately disqualified. So we're going to say if not curchar.isDigit. So if the current character is not a digit, immediately disqualified. False. It's not an integer. Otherwise, we simply say number has been seen. So we're going to mark it as true. And we're going to move our I pointer up. And now, once this while loop breaks, either it will be because we disqualified the number and it's not an integer because we saw something that wasn't a digit, or we've now hit the end, and now we simply, again, need to return whether we've seen a number. So we're going to say return number seen. So that is how we write the isValid integer function. And remember, it's going to be used here when we see an e. And just to recap, when we see an e, we need to have seen a number before it, right? Because if we look at this example, e3 is not valid because there was no number before it, right? And we need to have a valid integer after it. So, right, and then this one, it does have a number before it, but because the number after the e is a decimal, obviously that's not an integer, so it's not allowed. Everything after the e must be followed by an integer. So that's why we've seen a number by this point, and everything after the e is a valid integer. So I'm just going to run this, make sure I haven't made any bugs here, just because it's quite a long solution. And it looks like, cool, it is running. Now let me submit this. And false. Oh boy. Let me see. Decimal used. If decimal used equals true. Why is that false? I found this stupid bug. It's actually if s of I in this one here. I think I had equals equals, so that is why it wasn't running. That recording was like 12 minutes long. I'm not going to re-record it. So I think now if we submit, it should be fine. Okay, perfect. There we go. Yeah, stupid mistake there. I had it right down here, but up there I just said double equals. So, okay, so what is the time and space complexity for this algorithm? Well, the time complexity here, obviously we have to, in the worst case, go from left to right over our, number here, all right? Our string representing a number. So in the worst case, we're gonna have to go from left to right and process every single character. So this is gonna be big O of n, where n is the length of the string, right? So that's your time complexity. And our space complexity is, in this case, all we do is define two variables to basically keep track of whether or not we've seen decimal. And that's essentially it. So our space complexity is gonna be big O of 1. So that is how you solve this question. Like I said, this is more handling all of the edge cases, reading the question, making sure like what's a valid input, what's not a valid input. This is something that you'd want to kind of discuss with your interviewer and figure out all of the cases, ask questions. Obviously on Leetcode, we're given all of these examples of valid integers, valid numbers, and we can kind of derive what is and what isn't one. But typically this is something that you'd want to kind of like discuss with your interviewer and figure out all of those cases. And that's really where this question's meat is. It's really, the details of like all of the edge cases and making sure you cover all of your bases. Again, this question isn't really that hard. All you're doing is iterating over a string from left to right. But, there's just so many places where you can go wrong, so many things you can fail to check. If you don't kind of take the time beforehand to kind of jot those all out or think them through, then you can be in trouble. But, videos like this basically just walk you through all of the cases and explain it line by line, and it should be relatively easy to follow. So that is going to be a solution for valid number. One of my favorite problems. It's pretty straightforward. There's just so many edge cases, so it's definitely a really good interview question. And if you're interviewing at, let's see who asked this, looks like Facebook and LinkedIn, there's a good chance that you might come across this, so definitely one to know. But it's pretty straightforward. Once you've seen it once, you can basically kind of just remember how you solved it, and it's quite easy. Anyway, I'm going to stop rambling because this video is probably 20 minutes long. Anyway, thank you so much for watching. If you could, please leave a like and a comment. It really helps with the YouTube algorithm. If you want to see more content like this, please subscribe to the channel. I have a ton of videos, and I plan on making a whole lot more. Anyway, thank you so much for watching, and have a great rest of your day.